Today we're going to be talking about algebra and how to go about doing it and what it is, starting from a level that assumes that you know nothing more than how to add, subtract, multiply and divide. So algebra is the foundation of maths. It's as important as knowing how to count. If you say you're bad at maths, most likely the reason is that you have not completely understood algebra. Algebra is the ability to be able to change a formula into a different form. There's only a couple of basic rules. So if we start off with a simple formula of 0 equals 0, algebra allows us to do whatever we like to that formula as long as we do it to both sides. So we can add 1 to both sides and that will give us 1 equals 1, which again 1 does equal 1. We can also multiply both sides. So if I multiply both sides by 2, I get 2 equals 2. I can subtract from both sides. So if I subtract 1 from both sides, then I get back to 1 equals 1. And the same thing goes with division. So I can divide both sides by 2 and that just gives me a half equals a half. And that's the basics of algebra, and there isn't a huge amount more to it than just being able to do that. But we've also got to talk about what's the purpose of doing this. Yes, we're allowed to add and subtract, multiply and divide to both sides as long as we do it to both sides. We normally do it for a purpose. So, for example, let's say we have our speed equals our distance divided by our time. And I got that formula just from thinking about how do we measure speed. Normally in the car it's kilometers per hour. Kilometers is a measure of distance, that's where I got the distance from. An hour is a measure of time, and that's where I got the time from. So I could use this just directly. So if I had known that we'd travelled 100 kilometers in 1 hour, then I would know that our speed was 100 kilometers per hour that we were travelling at. But let's say we're driving and we see a sign that says our destination is 200 kilometers away and our speed again was 100 kilometers per hour. We can use this information to rearrange this speed equals distance over time formula to get how long it would take us to get to our destination. So just starting off with our speed equals distance over time, as we're allowed to do anything we like to both sides, we can multiply both sides by time, and that will give us time times our speed equals our distance. Not what we want, but we can continue going with this. We can divide both sides by the speed, and that gives us that our time will equal our distance over our speed. Using the numbers which I suggested before, our distance was 200 and our speed was 100 kilometers per hour. So the time that it will take us to get to our destination will be 2 hours. So there's a simple example of where we can actually use it. To solve for a variable, you can follow the following steps. The first step is to copy the equation exactly. The second step is to identify which side of the equal sign for the variable you are looking for is. The third step is on the side the variable is on, find all variables, letters or numbers, which are not what you are trying to solve for. The fourth step is to identify the operators linked to the variables. After you have done that, the fifth step is to use order of operations to decide which variable identified in step 3 you will work on first. The sixth step is to apply the opposite sign with the variable identified in step 5 to both sides, and then the final step is to evaluate or simplify the resulting equation. And then if you have more than one variable which needs to be moved, you go back to step 1. On some equations, additional steps may be required. If at the final step the variable which you are looking for is negative, you can multiply both sides of the equation by -1 to make it positive. If the variable you are looking for is at the bottom of a division, you can move it to the top by multiplying both sides by the variable that you are trying to solve for. If the variable appears in more than one location, then you need to apply some combination of the earlier steps to move all of the instances of the variable you are looking for to one side of the equation and everything else to the other side of the equation. Factorize if required. Common errors when performing algebraic manipulations are the following: changing the sign of something which is copied instead of applying the same sign to both sides, not applying multiplication or division to the entire side, not choosing the opposite operator to apply to both sides of the equation. When the wrong operator is chosen, cancelling out variables which don't cancel, and finally combining variables which cannot be combined. For example, x plus x squared cannot be combined. As an alternative to writing what operator and variable you are moving to both sides, you can, for addition and subtraction, just take that variable and move it to the other side of the equation and swap the sign as it passes the equal sign. For multiplication and division, if the variable you are trying to move is on the top, it goes to the other side of the equation where it will be underneath the division line, and if the variable you are operating on is underneath the division sign, it can go to the other side of the equation where it will be above the division sign. So often it will come up that we will have an equation, for example, y equals mx plus c, which is the equation for a straight line. It's just a generic equation for the sake of demonstrating. C normally represents your y-axis intercept, m is generally your gradient, and this formula is used to a huge amount within maths. So one thing that we'd want to do is to be able to rearrange it for any one of those variables, not just y, not just m, not just x or c, just every single one of them. So how we can go about doing that is generally you choose a letter that you're going to try and solve for. So for this case, I'm going to try and solve for c. Then the process is that I look at the equation and go, what is on the same side but not the variable that I'm looking for? In my case, I have m and x. And then I think about the order which I do things. So we're taught that we always do multiplication and things in brackets first, followed by addition and subtraction. When doing this, the order is generally the opposite, or you could think of it as, you'll do your addition and subtraction and then move into your multiplication and your brackets. So in this case here, if I look at the terms which are not c, I've only got m and x. There's also an implied positive in front of that m, because when we write a number or a letter, which a letter represents a number, out the very front we often don't write the positive, just like when we write the number 1, we don't normally write +1. Following through with our idea, we've got a plus mx on the same side as what we have the c, but it's not with the c, therefore we can choose to subtract both sides by mx. That will give us that c equals y minus mx. So a lot of the point of doing this is you're thinking of things that you can either multiply or divide, that you'll get an answer of 1, or add or subtract so that you'll get an answer of 0. So now I've solved for c. I can also choose to solve for any other letter. So let's this time go for x. So to solve for x, again, I follow the same idea. So with the order of operations, I can see that the item that is furthest away is the y, because I would, if I knew the value for x, I would multiply the m with it first, and then the value of mx subtracted from y. So what I'll do now is I will subtract y from both sides, because there's an implied plus in front of y. So I got c minus y equals negative mx, and then because I'm aiming for x, going through the same process of what's on the same side, another thing I'm looking for, I've got negative m, so I just divide by negative m, and then I have x equals c minus y over negative m. And I can continue doing this for the m variables. So this is another thing. Generally, when your variables that you're looking for is on the bottom, you will move it up to the top before you work on it. So I've got negative mx equals c minus y by multiplying both sides by negative m, and then I'm in a very similar position to where I was before. So I can just divide both sides by negative x to get m. So m equals c minus y divided by negative x. Now, at any point through this, I need to check to make sure I haven't made any mistakes. And one way of checking is just to go back to where I originally started. And you'll always be able to go around in circles like this. You'll always be able to go back to where you started. So now I'm aiming for y, and I look at what I've got here. I've got my x, which is the last thing which I would do if I knew the value. So I will multiply both sides by negative x to get negative mx equals c minus y. On the same side as of y, but not y, I've got positive c, so I'll subtract c from both sides. And then I've got a negative y, so how I can get that to a positive y, so I get back to where I started, I can multiply both sides by negative 1 to bring it around to be positive, and then I get back to the beginning, y equals mx plus c. So with doing that, I can work the way through, and if I get something different to what I started with, I know I've made a mistake, and then I can look through what I've previously done to find that mistake. Also, going with checking, there are other ways of checking. There's several pieces of software you can use, including a graphics calculator where you can put in the question and ask it to solve. Another thing you can do is use a website or app called Mathsway, or Photomaths is also quite similar. You can just aim your phone at it and take a photograph and then ask it to solve for a particular variable. To use Mathsway, you just choose Algebra as your section, type in your equation as you would write it down, and then choose to solve for whatever variable that you need to, and then it gives you the result. Another way of doing it, which is a little bit more complicated, but gives you the ability to be able to continue on with more than one step in a problem and solve much more complicated problems, is Octave Online. So to use Octave Online, you will first need to enter in all the variables in your equation by writing sims and then listing out your variables with the space in between them all. After you've then done that, you can ask it to solve by typing solve, then writing in the equation with a double equals, and remembering to put in the multiply sign. If you don't, you'll get an error as shown here. It will again solve the equation for you. There can be times where you'll have an equation which you will have the thing you're looking for appear in more than one place, such as here. So I've got x both on the bottom and on the top. So what I need to do is I can still apply the same method of adding, subtracting, multiplying and dividing to both sides to be able to manipulate things around. So to begin with this one, I'll multiply both sides by x minus 1. It's always good just to copy exactly what you've done and then apply what you're doing to both sides. here I need to expand some brackets. After I have done that, I can then get all of my x's together and all of my other variables that I'm not looking forward to on the other side. And after I've done that, it just ends up going back to what I've shown before. So to begin with this one, I'll subtract x from both sides. Then I can add 3 to both sides. And then I have what x is by dividing by 2 on both sides. The final thing which can come up is sometimes you know that a particular variable takes on a value. That value could be anything. So for example, if I have two straight lines, let's say one equation is y equals x plus 1, which is just a straight line crossing the y-intercept at 1 and with a gradient of 1, and we have another equation that says x minus 2y equals 3. What I can do is I can work with one of these equations and solve for a variable. It doesn't matter which variable I choose. In this case here I'm going to use the second equation and solve for x. So I see on the same side I've got negative 2y, so I'll add 2y to both sides, where 2y minus 2y has to equal 0 because I'm subtracting the same thing. So a lot of the point of doing this is you're thinking of things that you can either multiply or divide, that you'll get an answer of 1, or add or subtract so that you'll get an answer of 0. Now that I have what x is, I can go to the first equation and replace x with the value of x that I've just worked out from the second equation. So y equals, so here I'm up to the x. I will replace x with what x is, which is 3 plus 2y. Then I'll finish off the equation, which is just the plus 1. And now I've got y in two locations. I can go through the method of solving. So I'll add the 3 to the 1, so y equals 2y plus 4. And then I can subtract 2y from both sides, again aiming to get 0 on the thing which I don't want on that side. So then I get negative y equals 4, and then multiplying both sides by negative 1 because two negative values become a positive, so y equals negative 4. This covers a great deal of the problems which are going to come up in maths.